Hello everyone, I am Karan Mashru. Welcome to this video. So in this video, we are going to discuss the solution of the problem eventual safe states. First of all, let us start by understanding the question. What does question say? A directed graph of V vertices and E edges is given in the form of an adjacency list ADJ. Okay, so we are given a directed graph, means each edge has a direction associated with it. It has V vertices, E edges, and an adjacency list is given. Each node of the graph is labeled with a distinct integer in the range 0 to v minus 1. So these are the numbers of the graph. A node is a terminal node if there are no outgoing edges. Okay, so if a node does not have any outgoing edges, then we call it a terminal node. A node is a safe node if every possible path starting from that node leads to a terminal node. When a node is called a safe node, when starting from that node every path leads to a terminal node. Okay, each and every path. So even if there is one path which does not lead to a terminal node, we do not call it a safe node. Okay, and what is terminal node? A node which does not have any outgoing edges. You have to return an array containing all the safe nodes. So we have to return an array which has all the safe nodes, means the nodes in which every path leads to a terminal node. The graph should be in ascending order, sorted in ascending order. Okay, so if we look at this example, so here see what's happening is, see if we look at 0, see what are the terminal nodes. 6 is the terminal node because there is no outgoing edge. 5 is the terminal node because there is no outgoing edge. From 3 there is outgoing edge, from 0 there is outgoing edge, from 1 there is outgoing edge, from 2 there is outgoing edge, and from 4 there is outgoing edge. Okay, so 6 and 5 are terminal nodes. Now what are the nodes whose starting from where all the path leads to a terminal node? So if we look at the answer, it is 2, 4, 5, 6. Now obviously 5 and 6 will be in the answer because those are terminal nodes. If we look at 2 and 4, so starting from 2 there is only one path which will end at 5, which is a terminal node. From 4 there is only one path which will end at 5, which is a terminal node. If we look at 0, 1 and 3, see starting from 0 there is a path to 2 and which goes to 5, and 5 is a terminal node. So starting from 0 these path ends at terminal node. But if we look at other path from 0 to 1, 1 to 3, and from 3 to 0, it again comes back to 0. Okay, so this path 1, 3 and 0, it does not end at a terminal node, it's keep revolving. Okay, similarly for 1, 3, 0 and for 3, 0, 1. So 0, 1 and 3 do not have all the paths which end at a terminal node. There is some path which does not end at a terminal node. So these are not safe nodes, and 2, 4, 5, 6 are safe nodes. So that is the answer. This is the second example. Output is 3. You can read the explanation. You don't need to read or print anything. Your task is to complete the function eventual safe nodes, which takes integer v denoting the number of vertices and adj denoting adjacency list of the graph, and returns an array of safe nodes. The expected time complexity is big O of v plus e, expected space complexity is big O of v, and the constraints are given here. So now if we think about solving this problem, then first of all let us recall the two terminologies. One is the terminal node. What is the meaning of terminal node? A terminal node is a node where there are no outgoing edges. So if in this graph if we look, what are the terminal nodes? 8 is a terminal node and 7 is a terminal node. No other nodes are terminal node because others have an outgoing edge associated with it. The other thing was a safe node. Okay, now what is a safe node? If all the paths starting from a node, please hear it clearly, if all the paths starting from a node leads to a terminal node, then that node is called a safe node. Okay, not one path or two paths, all the paths which are starting from that node, if they lead to a terminal node, then it is called a safe node. Even if there is one path which do not end at a terminal node, then that is not a safe node. Okay, so if I look at the example, see if we look at 1, so starting from 1, one path is 1, 2 and 7. Okay, now this ends at a terminal node 7. But if I look at another path 1, 2, 3, 4, 5, 6, here my path ends, or you can again go back to 3 because the edges do not get repeated in a path. So one path is 1, 2, 3, 4, 5, 6 and again 3. Now in this path the path ended at 3, but 3 is not a terminal node. It means 1 is not a safe node, because starting from 1 all the paths are not ending at a terminal node. Okay, see there is one more path 1 to 2, 2 to 3 and 3 to 8 that ends at a terminal node, but all the paths starting from 1 do not end at a terminal node, so 1 is not a safe node. Okay, now by observation if you look a little bit more carefully, then you can say that if a node is a part of a cycle in the directed graph, or if a node leads to one of the nodes of a cycle of a directed graph, then that is not a safe node. Okay, understand one thing. Let us suppose there is no cycle in the graph. Okay, then starting from one node, somewhere the path will end. If there is no cycle, then the ending point will not have an outgoing edge. Are you getting my point? If starting from a particular node, if there are no cycles in the graph, let us assume, then starting from one particular node, if we start any path, it will end at some node. Now, since there are no cycles, so when will the path end? When that node will not have outgoing edges, so it will be a terminal node. So if there are no cycles, then all the paths lead to a terminal node, right? So whenever a particular node leads to a node of a cycle, or a node is a part of a cycle, then that cannot be a safe node, because it will be contained in that loop of nodes of cycle, and the nodes which are in the cycle are not safe nodes, because they themselves are not terminal nodes. So that cyclic path does not lead to a terminal node. For example, here we have cycle 3, 4, 5, 6, right? This is a cycle. So none of these are terminal nodes. Why? Because they have outgoing edge, then only they will form a cycle. And if I look at this cyclic path 3 to 4, 4 to 5, 5 to 6 and 6 to 3, then if I look at this path, my path is not ending at a terminal node, right? Because all the nodes of the cycle are not terminal nodes. So even if I start from 4, 4 to 5, 5 to 6, 6 to 3 and 3 to 4, so I ended at 4. 4 is not a terminal node. So what I am trying to say is, all the nodes which are part of a cycle are not terminal nodes, and if we consider this cycle, then if we consider this cyclic path, then it does not terminate at a terminal node, because these are not terminal nodes. Hence the nodes which are a part of the cycle are not safe nodes. Now if there is a node which leads to a cycle, for example 1, there is a path from 1 to 3 and 3 is a part of the cycle, right? So as soon as I am able to reach to one of the nodes of a cycle, now I can again traverse that cyclic path and I will not end at a terminal node. For example, I started at 1, I went to 2, from 2 I went to 3. 3 is a part of cyclic node. Now I can traverse that cyclic path and I will not add at a terminal node, because the nodes which are a part of the cycle are not terminal nodes. Okay. So the conclusion is, if a particular node has a path which reaches to a node of a cycle, or a node is itself a part of a cycle, then these are not safe nodes. Other nodes which are not a part of cycle nodes, as well as they do not reach to any of the nodes which is a part of the cycle, they will be safe nodes, because all the paths starting from that node will end somewhere, and that node and the ending node, if that is not a part of a cyclic node, it should be a terminal node. Okay, then only the path will end. Okay, so if we look at 8, so there is no outgoing edge from 8. Okay, you can also assume, let's say 9. Okay, so 9 is a terminal node. Now 8 is not a terminal node, 9 is a terminal node, and 7 is a terminal node. But starting from 8, I can go to 9. 9 is not a part of any cyclic node, so this path starting from 8 will end at a terminal node. So 8 is a safe node. Similarly, 7 is a safe node, 9 is a safe node. But any node which leads to a part of the cycle, or any node which is a part of the cycle, are not safe nodes, because this cyclic path will not end at a terminal node, for example 3, 4, 5, 6, and hence it will not be a safe nodes. Okay, so now let's think about how we will implement this. So now if we think about this implementation, so what we will do is, we will take 3 arrays. One is the visited array, which will basically mark a node visited whenever we will visit it. One is a path array, which will basically be true if it is a part of the current node. Okay, so for example, if it is a part of the current path, okay, not node. For example, if I am considering the path 1, 2, 3, 4, so this is a path 1 to 2, 2 to 3, 3 to 4. So these 4 nodes will be marked as true, because they are the part of the path I am currently considering, and others will be false. Okay, we will implement on this, you will get a better idea. And third array is the cycle array. So cycle array is basically, if it is true, it means that that node is either a part of the cycle, or that node reaches to a cyclic node. Okay, So for example, 1 reaches to 3, 3 is a part of cycle. So cycle of 1 will also be true. Okay, cycle of 3 will also be true. So cycle of I will be true if that node, ith node, is a part of the cycle, or if it reaches to one of the nodes which is a part of the cycle. Eventually, if cycle of I is true, it means it is not a safe node, and cycle of I will be false whenever a node is not a part of cycle as well as it does not reach to any cycle. So if cycle of I is false, it means it is a safe node. Okay, so what we will do, by default we will assume all the nodes to be a part of the cycle or to be reaching to some cycle. Okay, so none of them are safe nodes. By default we will assume that. Okay, visited we will mark false by default, and since we are not considering any path, so I will mark false initially. Okay, I have not started traversing the graph. Now understand one thing. So basically I want to find out what are the nodes which are a part of the cycle or which leads to a cycle, right? So what I'll do, starting from 1 to 8, I'll start calling a DFS whenever a node is not visited. Then after calling a DFS, I'll keep a mark of these things, visited and path. Okay, and we'll keep on changing cyclic as and when required. When there will be cycle, whenever we encounter a node while traversing the graph which is already visited before and which is also a part of the path, okay, which is already visited before, so visited of I will be true, and which is also a part of the current path, at that time we will get a cycle. You will get these words when we will dry run on this. So I'll start with 1. Okay, so I'll call a DFS on 1 because it is not visited. I'll call that 1 and I'll mark path of 1 as true, and my current path under consideration will be, current path will be 1. Now from 1 I can go to 2. I'll look in the adjacency list. 2 is not visited before, so I'll visit it. I'll mark it at true, and it is a part of the current path, and my current path will become 2. Okay, 1 2. Okay, then from 2 I'll go to 7. Okay, so 7 is not visited before, so I'll mark it as visited. I'll add it to my current path, and my current path would be 7. Okay, now from 7 I cannot go anywhere further, right? So I'll come back. Now whenever I'll come back, I have not encountered a cycle till now. It means that it is not a part of any cycle as well as it is not leading to any cycle. Are you getting my point? We are backtracking from 7. I went from 1 to 2, from 2 to 7, and now I am backtracking. It means that 7 is not a part of any cycle and it is also not leading to any cycle. So what I'll do, I'll mark this as false, and I'll also mark this as false again. Why? Because I have to remove it from my current path. So my current path will become 1 and 2. Okay, now from 2 I can go to 3. So I'll go to 3. 3 is not visited before. I'll mark it as 2. I'll mark here also 2 and add it to my path. So my current path will become 1, 2 and 3. From 3, let's say I go to 4. So I'll mark this as true, visited as true. This is a part of my current path. My path will become 4. From 4 I'll go to 5. So I'll mark this as true. I'll mark this as true, and my current path will become this. From 5 I can go to 6. So I'll mark this as true. I'll mark this as true, and I'll add 6 to my path. From 6, now here we have encountered a cycle. How? Because from 6 I can go to 3. 3 is visited before. Understand one thing, 3 is visited before as well as it is a part of the current path. Why? Because it is here as well as path of 3 is true. It means it is a part of a current path. Only then I can get a cycle. Okay, understand one thing. Suppose here there is 1, here there is 2, here there is 3, and there is a edge here. Okay, now from 1 I went to 2, my path is 1 and 2. From 2 I went to 3, my path is 1, 2, 3. Okay, now I'll backtrack, my path will become 1, 2. I'll backtrack, my path will become 1. Okay, but all the nodes are visited. All the nodes are visited. Now I'll see from 1 I can also go to 3, because in the first time I went from 1 to 2 and 2 to 3. But after backtracking, I see that I can also go from 1 to 3. But 3 is already visited before. But 3 is not a part of the current path. Current path is only 1. So it is not forming a cycle. Understand? From 1 to 2, 2 to 3, and from 1 to 3. This is not a cycle. This can be a cycle. Okay, this is a cycle, but this is not a cycle. So whenever we encounter an edge towards a node which is visited before, as well as it is a part of the current path, then only it forms a cycle. Here from 6 I have encountered an edge towards 3. 3 is visited before, it is also a part of the current path. So I have a cycle 3, 4, 5, 6 and 3, and we can also see here. So we have encountered a cycle. It means that all the nodes which are currently in my path are either a part of the cycle or are the nodes which leads to cycle. 3, 4, 5, 6 are part of cycle, and 1 and 2 are nodes which leads to a cycle. So I will not call DFS further. I will just return true and come back out of the function. I will just backtrack. Okay. So I'll backtrack and come back to main function. So what will happen, that 1, 2, 3, 4, 5, 6 are visited as true, and their cycle is also true. It is not changed. Only cycle of 7 is changed. It means that these nodes are a part of cycle or leads to a cycle. Okay, I started calling DFS from 1, right? Now from 1 I'll go to 2, but 2 is already visited, so I'll not call a DFS. Similarly for 3, 4, 5, 6 and 7. Then I'll go to 8. 8 is not visited before, so I'll call a DFS starting from 8. So my current path will become what? 8. This is marked as visited. This is marked as visited because it is a part of my current path. Now from 8 I cannot go further. I have to backtrack, right? But during backtracking, it is not encountered as a cycle. Whenever we encounter cycle, we just come out of the function, right? So that this remains true only. But here we have not encountered a cycle. So we will mark this as false. It is not a part of cycle, neither it is reaching to any cycle. And then we'll come out of this function also. So what we concluded, 1, 2, 6 are a part of cycle or reaching to a cyclic node. 7 and 8 are safe nodes because they are not a part of any cycle and they are neither reaching to any cycle. So now what we will do, we will simply traverse the array, and whenever cycle of I is false, that is a safe node, we will add it to our answer. Now let's look at its actual code. So if we look at the actual code, so we have been given the number of vertices and the adjacency list. So I have taken one vector answer in which we will store all the safe nodes. Then I have taken some variables ij to traverse. I have taken one visited array, visited of v. Whenever we visit a node in DFS, we have to mark it as visited. That is for that. Okay. Then I have taken one cycle array. So basically, if cycle of I is true at the end, it means that node is not a safe node, and if it is false, it is a safe node. And I have taken one path boolean array. So whenever I visit a node, I'll mark path of I as true. It is a part of the current path. Whenever I'll backtrack, I'll mark path of I as false, because now I'm backtracking from ith node and it is no longer a part of my path. Okay. So I'll make a for loop from I equal to 0 to v minus 1, path of I as false, visited of I as false, and cycle of I as true by default. By default, we are assuming no nodes are safe nodes. Okay. Then I'll go from 0 to v minus 1, and if visited of I is false, I'll call a DFS. Starting from ith node, I'll pass the visited array, cycle array, adjacency list, and path array. Okay. So now let's look at the DFS function. So what I have done here is I have first of all marked the ith node as true because I visited the ith node, and made path of I is true because ith node is part of the current path. Then for all the nodes which are in the adjacency list of I, now I have to traverse further the DFS. If visited of x is false, it means if that adjacent node is not visited, then call DFS. But if DFS returns true, it means that we have found a cycle. While calling DFS, we have found a cycle. It means that starting from current node, that is ith node, we were able to reach to a cyclic node. Okay. So we will just come back out of the function. So we'll just return true. Okay. We'll not further loop. If the visited of x is false, and if we found a cycle after calling DFS on x, we'll return true. If we do not find cycle, we'll go back to the next node. But if visited of x is true, it means that that node is visited before. When can we say it is a part, it is forming a cycle? When that node is visited before and it is also a part of the current path. So if this is true, then we will come here. So if visited is true, and else if path of x is true, it is also a part of the current path, then only we have formed a cycle. So we will return true. If path of x is false, it does not form a cycle, we'll again call DFS on the next element. Okay. So whenever we find a cycle, we just return true. Now if we didn't return true in any of this, it means we have not found a cycle starting from the ith node. If we have not found, then we will mark cycle of I as false. It means starting from ith node, we are not reaching to any cyclic node, and neither I is a part of any cyclic cycle. Okay, so it is a safe node. So we'll mark cycle of I as false, path of I as false, because we are backtracking from I will be removed from our current path and we will return false. That is, starting from I, we were not able to find any cycles further. Okay, so at the end we will make a for loop of size v, and if cycle of I is false, it means that that is a safe node. It does not reach to a cycle, or it is not a path of any cycle. Then we will push that node in the answer, and finally we'll return the answer vector. If we talk about the time complexity, so basically we are calling a DFS, so the time complexity of DFS is big O of v plus e. And if we talk about the auxiliary space, then here we have taken some arrays like visited, then we have taken path, cycle, all these arrays are of size v. So the auxiliary space which was required is big O of v, that is nothing but the number of vertices. Now let's submit this code. So let's submit it. So we have solved this question successfully. I hope you understood the solution completely. Thank you.